In this video, we'll take a look at how to solve a multiple angle trigonometric equation. So we want to solve the tangent of 4 times x is equal to the square root of 3 in the interval of 0 to 2 pi and want to make sure we have exact solutions. So now we have tangent 4x, not just tangent x, but we follow the solution steps the same way. Okay, I'm going to show you a graph first of what this looks like. So remember the tangent of 4x, the period of tangent is pi. So this is 4 times x. So the period of tangent 4x is pi over 4. That means we're going to have a lot more solutions in this interval. So using Desmos, I typed in a graph. So let's see what that looks like. So if you type in tangent 4x and then type in the other side of the equation, g of x is equal to the square root of 3, you can see that between 0 and 2 pi, the period of tangent is pi over 4. So actually 2 complete cycles of tangent are there between 0 and pi over 2. Usually it's just one cycle. So notice I've also graphed square root of 3. Wherever these two graphs intersect are all the solutions. So notice how many solutions we're going to have. 1, 2, 3, 4, 5, 6, 7, 8, and then this solution is beyond 2 pi. So we're going to end up with 8 solutions. So let's see how we do that by hand, and then we'll come back to the graph and see, check and make sure that we've got it right. So the first thing we do is take the inverse tangent of each side. So 4x is going to equal the inverse tangent of the square root of 3. So I've got to find on the unit circle, where does the tangent, the square root of 3, and that will be my angle. So taking a look at the unit circle, notice that tangent is sine divided by cosine. So I want the places on the unit circle where the sine divided by the cosine is equal to the square root of 3. Sine divided by cosine would be y-coordinate divided by x. So as you look in the unit circle, when you divide these, to get positive answer, it'll happen in the first quadrant, right here. If we take the sine, square root of 3 over 2, divided by a half, we end up with the square root of 3. So we get pi over 3 is where the tangent is equal to the square root of 3. So the other place, since tangent repeats every pi, if I added pi to that, I would end up over here at 4 pi over 3. So, or down here at 4 pi over 3. So I'm going to use the solution pi over 3 because when I keep adding pi to it, I'm going to end up with all the solutions. Okay, so pi over 3. So I'm going to use the fact that the inverse tangent square root of 3 is pi over 3. So now I have an equation 4x is equal to pi over 3. I know that the tangent equation repeats every pi, so I'm going to add pi to this so that I can get all of the answers that I need. So now I don't have just x is equal to, I have 4 times x. So to get x by itself, multiply both sides by a fourth. And I'm going to multiply this entire expression times a fourth. And you'll see why I have this pi right here. So I have pi over 3 times 1/4 is pi over 12, plus pi times 1/4 is pi over 4. So now remember when we looked at the graph, our tangent equation repeats every pi over 4. And the first time that the tangent of 4x is equal to the square root of 3 is at pi over 12. So now what I want to do to get all the answers is just keep adding pi over 4 until I get all of the answers between 0 up to but not including 2 pi. So pi over 12 is my first answer. Then I'm going to pi over 4, change it to, so they have the same denominator so I can add them together. Pi over 4 is 3 pi over 12. So pi over 12 plus 3 pi over 12 is 4 pi over 12. Reduce the fraction, that would be pi over 3 is the next place. Then I'm going to take it and add pi over, I'm going to take my answer, 4 pi over 12, and add 3 pi over 12 again. So 4 plus 3 is 7 pi over 12. And I keep adding 3 pi over 12 until I get all of my answers. Okay, so I'll reduce them after I add them all. I probably shouldn't reduce this one. So this one would have been, if I add 3 pi over 12, that's 4 pi over 12. Plus 3 is 7 pi over 12. Plus 3, 10 pi over 12. Plus 3 more, 13 pi over 12. Plus 3, 16 pi over 12. Plus 3, 19 pi over 12. 3 more, 19, 20, 21, 22 pi over 12. And if I added one more, I'd have 25 over 12, which is bigger than 2 pi. Then you can go back and you can reduce your fractions. So that's pi over 3. 10 pi over 12 reduces to 5 pi over 6. 16 over 12 reduces to, let's see, 4 goes into both. 4 pi over 3. 19 pi over 12. And 22 pi over 12 reduces to 11 pi over 6. So there are 8 solutions to this equation on the interval between 0 and 2 pi. So let's take a look at the graph again in Desmos and make sure that we've captured everything. Okay, so now if I take a look, I can click on Desmos, and I've set, just so you know, I've set this using radians between, I put originally 0 and 2 pi in there, but I made it just a little bit shorter so you could see it. And I used a step of pi over 2. So now when we look at these, if I'm going to click on each of these, there's pi over 12, pi over 3, 7 pi over 12, 5 pi over 6, 13 pi over 12, 4 pi over 3, 19, and 11 pi over 6. So there are all of our solutions to the equation. So you can look at it, solving the equation. You can use the unit circle to help you get that first solution, and then think about what the period is when you have multiple solutions. Then when you multiply both sides to get x by itself, then you'll have your first solution and you'll know how often it repeats.